Okay, so these are the three equations. Now let's look at the first question. The specific heat of ice is what? Solid is given. Calculate how much of heat energy is needed to heat 52 grams of a sample of ice from minus 20 to 0 degrees Celsius. Is the temperature changing? Is the temperature changing? So, who can tell me what equation I have to use? What is the equation I have to use to solve the step? The temperature is changing. Yes. MCAT equation. Q equals M times Cp of the solid times delta T. Therefore, my Q equals, what is my mass? My mass is 52 grams. 52.0 grams times my specific heat is 2.06 joules over grams degree Celsius. Now let's pay very careful attention to the temperature. Is 0 my T final? Is 0 my T final? And negative 20 is my T initial. The beginning temperature is negative 25 and it goes to 0 degrees Celsius. Do you all agree? Change in temperature is always T final minus T initial. Is that right? So it should be 0 minus minus 20. What is minus of minus 20? Plus 20. Have you learned this in a math class? Minus of minus 20 is plus 20. So what is my change in temperature? 20 degrees Celsius. Is everybody good? And therefore, my answer, right now I'm not going to look at sig figs. Is that clear? So I have 52 times 2.06 times 20 and I get my answer as 2142 joules. Alright? So the substance has moved from here to here. Is everybody good? What is the next step? The substance, after it's gone to 0, what is going to happen to the substance? It's going to melt. Is that right? Step 2, it's going to melt. So delta H fusion, enthalpy of fusion means what? Delta H fusion. Is that right? Delta H fusion is given and the mass is given. Can somebody tell me what equation do I use when it is melting? What equation do I use when it's melting? What is it, Keith? The first one. Very good. Q equals, Miss McGrain, he deserves candy. Alright? M times heat of fusion. That's equal to 52.0 grams times 334 joules over gram. Is that right? Very good. So now I'm going to multiply 52 times 334 and I get 17368 joules. Alright? 17368 joules. Okay? The substance has now melted and it's now here. The substance has melted and it's now here, it's become all water. What is the substance going to go through next? What is the state of the substance between this to this? What is the state of the substance between these 2 points? What is the state of the substance? It's a liquid. What equation will I use to solve my heat change for that slope? Who can tell me? Is it second? Is it becoming a vapor there?
Yeah.
It is the third. Along the slope Snebe, it is mCp delta T. So my equation will be Q equals M times Cp times delta T. My specific heat is now specific heat of a liquid. Is that right? So my math is 52.0 times, this is my specific heat, 4.18 joules over grams degree Celsius, times, what is the change in temperature? This is T initial, 100 is my T final. So 100 minus 0 is what? 100 minus 0 is 100. So I have 100 degrees Celsius as my change in temperature, and now I calculate 52 times 4.18 times 100 equals 21736 joules. Everybody good? So where is the substance now? The substance has gone from 0 to 100. Is that right? What is the next step the substance will go through? What will happen to the substance next? It's going to boil. So that is my next step. What is my equation I will use when it is boiling at 100? What equation will I use? Who can tell me? It's boiling. It's in the flat line. So what is the equation? Huh? HVAC? Very good, Karen. So it's Q equals M times enthalpy of vaporization. So it's still 52 grams times 2260 joules over grams. Enthalpy of vaporization means HVAC. Is that right? So now I multiply, and it is 52 times 2260 equals 117520. All right? Everybody good? Now what is going on? So the substance has reached this end. It has all become vapor. And then what will happen to the vapor? Vapor or gas. What will happen? The vapor or gas will increase in temperature. Is that right? So my last and final equation is Q equals M times Cp of the gas times delta T. Is that right? And my mass of the substance is 52 grams. My specific heat of gas is 2.02 joules over grams degrees Celsius. What is the change in temperature? T final is 120. T initial is 100. Is that right? So it's 120 minus 100, which is 20 degrees Celsius. Right? 120 minus 100 is 20. Everybody good? So my next answer is 52 times 2.02 times 20. Oh, wait. All right. So 52 times 2.02 times 20. I get 2100 joules as my answer for this step. So now I have 5 different calculations. Is that right? What is the total energy of the substance going from here? So it starts here and it ends here. Is that correct? Everybody with me? Is it going through 5 different steps? Yes? Is it going, did we do step 1, step 2, step 3, step 4, step 5? Did we do 5 different calculations? So what is the total energy? What do we do with these 5 answers at the end? You add them all up. Very good. So all I'm going to do for step 5 is I'm going to add up everything. And if I add up everything on my calculator, I get 2142 plus 17368 plus 21736 plus 117520 plus 2100, and I get my answer as 1068 866 joules. I'm going to round to 3 sig figs because most of my numbers are 3 sig figs. I'm going to round at the end. So I'm going to say it's 161 and all these 3 will turn into zeros. So many joules. Is everybody with me? Do you understand the problem? Okay. So you will get a problem like this on your test. Okay? Let's go to the next page. Let's go to the next page. Here is a problem type you will get. Okay? You will just be given. Is everybody listening? Is everybody head in this class? Okay. I'm going to make up, I need all of you to write a practice problem here. Write down practice heating cooling curve. Write that down. Practice heating cooling curve. Practice heating cooling curve. Alright? I know this table is here. Alright? But I'm going to make up 2 different numbers just for the practice heating cooling curve. Is everybody with me? So what are the 2 numbers I'm going to make up? I'm going to say the melting point, here it says 0. Is that right? I'm going to make up a new number. I'm going to say the melting point is 20 degrees Celsius. Is everybody with me? Are you, I right? You right. Everybody's pencil should be moving on their paper. This is the melting point, and I'm going to say the boiling point is 60.0 degrees Celsius. Alright? If I know the melting point and the boiling point, I can draw my heating cooling curve. They do not have to give me the heating cooling curve. Does everybody understand this? How do I draw my heating cooling curve? So the first thing I need is my axis. Draw your axis. Draw your x and y axis. What is your melting point now? What is your melting point? 20 degrees Celsius. Is that right? So draw a flat line. Draw a flat line a little further away, and what is the melting point again? 20 degrees Celsius. Everybody okay? So that is the first thing you need to do. Okay, I'll make a flat line for my melting point. What is the next flat line for? The next flat line is for boiling point. Is 60 higher than 20? So I'm going to draw a flat line further away, and I'm going to say that is my 60 degrees Celsius. Is everybody okay? Now I can make my 3 states of matter. This is my solid, that is my liquid, that is my gas. So it's a solid, liquid, and gas. Let me ask you a question. The substance is at 70 degrees. What is the substance at? 70 degrees. Is the substance a solid, liquid, or gas? It's a gas. Is that right? It's above 60. The substance is at 10 degrees. Is it solid, liquid, or gas? It's a solid. The substance is at 40 degrees Celsius. What is the substance at? Liquid. The substance is at 20. What is happening to the substance at 20? It is melting. What is happening to the substance at 60? It is boiling. You should be able to make these links. You will be given a table. You will just be given the melting point and the boiling point. Do you think you can draw the heating cooling curve by yourself? For the big problem, the 5-step problem, the first thing you should know is how to draw your heating cooling curve, how to recognize where is it a solid, where is it a liquid, where is it a gas. You think you can do that? Everybody good with that? Okay. And then you will be asked to solve the problem. Okay? Let's switch back to this data table. Okay? We learned how to do this, but I'm going to switch back. Please remember, on your test, it's not going to be 0, it's not going to be 100. It's going to be some other number. But I'm positive that you can draw the graph. Is that right? So now let's look at this problem. Okay? They've given us the melting point. What is the melting point according to this table? 0. Where is it on this graph? Where is 0? Can I extend this and say this is 0? Is this my melting point? Jackie? Everybody good? Is that my 0? Okay. What is my boiling point? What is my boiling point? 100. So, let's draw this flat line. And what is the boiling point? 100 degrees Celsius. That's the first thing I need to know to do. Everybody good? Okay. So now, let's read the problem. They're asking you to calculate the heat required to heat 5 grams. What is 5 grams? Is it specific heat? Is it mass? What is it? It's the mass of the substance. Now, they want you to go from -10 to 20. You cannot say, oh, there is a temperature change. Is there a temperature change? -10 to 20? Is it changing? You cannot directly say, oh, I'm going to use this equation. It is more complicated. This problem is more complicated. It involves more steps. Let's see. Can somebody tell me where is -10 on this graph? Is it below 0? Is it -10? All right. So it is -10 degrees Celsius. Can somebody tell me where is 20? Can I say this is 20 degrees Celsius? Is this line 20 degrees Celsius? This point? Everybody good? Is this point -10? Did we plot the 2 points? So, what are the changes the substance is undergoing? First, is this going through this slope? Yes? That is the first change it's undergoing. What is the second change it is undergoing? This is the first step in the slope. What is the second step? What is happening to the solid? It's melting. That's step number 2. That is step number 2. Then what is happening to the liquid? The liquid is increasing in temperature. Do you see that? That is step number 3. So, I have to do 3 different calculations. And what do I do with those 3 numbers that I get? Add them up. Do you understand? So, when you are given a question like this, you have to be really careful. Do we hear that? Okay. So, what equation will I use for step number 1? Gabby, I'm right here in step 1. What equation will I use for step 1? It's a slope. What equation will I use? What equation? We did a whole previous problem. Go to the other page. What equation do we use along slopes? What do we use? If it's a slope, what do we use? M cap, right? If it's a slope, we use M cap, right? So, Q equals M times, give it a pass, M times, all heads up, M times, the second letter is specific heat, okay? What is the state of the substance here? Is it a solid, liquid or gas? What do I need? Do I need specific heat of solid, liquid or gas? specific heat of solid times delta T. Are we good? It's M times specific heat of solid times change in temperature. There are two areas where you have to think. Alright? What is my mass? 5 grams. Is that correct? I will choose 5.0 grams. Now times, which specific heat will I choose? Will I choose solid, liquid or gas? Which specific heat should I substitute? Specific heat of solid. Unless you know it's a solid, you don't know how to choose. Is that right? So which number am I going to choose? 2.06 joules over grams degrees Celsius. Is everybody good? Let's stop and think. For delta T, let's stop and think. It's going from minus 10 to what is this temperature? It's going from minus 10 to what temperature? 0. What is my final temperature? 0. What is my initial temperature? My final temperature is 0. What is my initial temperature? Negative 10. 0 minus of minus 10 will be my change in temperature. Does everybody understand that? What is 0 minus of minus 10? Plus 10. So, that's my change in temperature. And so, if I multiply, what do I get? I get 5 times 2.06 times 10. And my answer is 103 joules. Is that right? I only have done step 1. What should I do next? I've only done step 1. What is my next calculation? My step 2. Is that right? What is happening in step 2? It is melting. So, in my step 2, what is my equation? Q equals M times heat of fusion. Is that right? The mass of my substance is 5 grams. Now, I need to find heat of fusion from the table. Where is my heat of fusion? Which number is my heat of fusion? Which is my heat of fusion? Is this delta H fusion? Everybody can see that? Does everybody know to pick that number? Alright? If you pick a wrong number, will you get the answer right? Are there questions on that? Times 334.16. And now if I multiply, I get 5 times 334.16. I get 1671 joules. So what have I done? I've done my step 2. Where is my next calculation? Where is my next calculation? Which is my next calculation? Step 3. I'm now on the slope. Gabby, what equation do I use when I'm on the slope? You have to keep your head in the class. If you are not processing information, it's very difficult for me to teach. Alright? You have to keep your head in this class. You cannot be like, I'm thinking about what I ate yesterday. I'm thinking about what TV show that I saw yesterday. And if you're not thinking, I cannot teach. Yes, Louis. NCAT. Q equals step 3. Step 3. So what is my equation? Q equals M times. Let's stop and think. What specific heat should I use? Is it a Marvi? Very good. So specific heat of the liquid times delta T. Is that right? So my mass is 5.0 grams. Which specific heat will I choose from the table? Specific heat of the liquid, which is 4.184 times Let's stop and think. Let's stop and think about delta T. Step 3. Where did it start? What temperature did it start? 0, not -10. It started at 0, and what did it end at? 20. So what is your change in temperature? 20 minus 0, which is 20. So you really have to be careful about choosing the right value and the right temperature change. Do you understand? Otherwise, you'll mess up your problem big time. All right? So it's 5 times 4.184 times, wait, that was wrong. I typed it wrong. 4.184 times 20, and I get 418. Am I done? Am I done? What is my last and final step? What is my last and final step? Keith, what am I supposed to do? Okay, draw the line, fine. I will draw the line, but I'm still not done. What is my last and final step? I solved it for step 1. I solved it for step 2. I solved it for step 3. What is my step 4? What do I do? You have to add them all up. You have to add them all up. Alright? So my step 4, guys, I'm running out of place here. Do you mind if I write it below the problem? Step 4 is, I add up all these numbers, which is 103 plus 1671. Is everybody able to see what I'm doing here? Plus 418 joules, which is equal to what? 103 plus 1671 plus 418 equals 2192. Is that right? 2192. Is that right? I would round to 3 significant digits, and I'm going to report my answer as 2190 joules. Everybody good? You understand? Do you understand the problem? Do you understand how it is a more complicated problem? Do you understand you have to go through the various steps? Have you written it out? Can we do the next problem now? Alright? Let's do one more problem. Alright? I'm going to erase this. Are you guys okay with me erasing this? Everybody has it down? Okay? Who said that? Okay, Mustafa. Do you feel like your brains are getting fried?
Yeah.
Oh, I'm sorry. You will be given a 5-step problem on your test. Alright? You should add up everything and do it right. Okay? Can I erase it now, Mustafa? Okay. So let's go to the next problem. Erase. Okay. Let's see. So the first thing I need to do is have my heating cooling curve. Is that right? So what is my melting point again? According to the table, my melting point is what? 0 degrees Celsius, correct? What is my boiling point? 100 degrees Celsius. Everybody good? With the melting point and boiling point? Okay. In this problem, what is the temperature change? Now read the problem carefully. The hot water or the vapor is being cooled. It is being cooled. What is my starting temperature? What is my starting temperature? 120. Is that right? So 120 is somewhere here. Everybody agrees? Okay, this is 120. What is the state of the substance at 120? What is the state of the substance here? It's a gas. What is the state of the substance here? It's a liquid. What is the state of the substance here? It's a solid. So, it is starting at 120. What is the final temperature? 50. Where do you think is 50? Can I say 50 is here?
Yeah.
Alright? 50 is somewhere there. how many steps will you calculate? 3. There you go. 3 steps. All right. So now step 1. Step number 1. It's a slope. MCAT. Q equals M times specific heat of solid, liquid or gas? Gas. Specific heat of gas. Specific heat of gas times delta T, change in temperature. We have to pay attention to detail. Otherwise, you'll mess up the problem. What is the mass of my substance? What is the mass of my substance? 10 grams. 10.0 grams. Now, from the table, I need to choose specific heat of gas, which is what number? 1.996. Every good? 1.996. So let's substitute 1.996. Oh, I can't write. Joules over grams degrees Celsius. Let's think. This is the point we need to think. The substance is cooling. What was my initial temperature? 120. What did it drop to? What is the final temperature? 100. And my change in temperature is my final. This is my final temperature. That is my initial temperature. It's always T final minus T initial. So, wait. Its final is what? 100. What is my initial? 120. What is my change in temperature? Negative 20. It is not positive. It is negative 20. Therefore, my math is 10 times 1.996 times negative 20 equals minus 399 joules. It's a negative number. Are we good? Step 2. What is happening at step 2? I did step 1. I'm now in step 2. What is it? What is happening here? Q equals M times. It is going in this direction. Gas is becoming a liquid. Gas is becoming a liquid. What is the change? Condensation. It is M times enthalpy of condensation. Okay? So my mass of my substance is 10 grams. I need to find my enthalpy of condensation. I'm going back to this table. I don't see an enthalpy of condensation. I only see an enthalpy of vaporization. What am I going to do? What is enthalpy of condensation? It is the same as enthalpy of vaporization, but what? With a negative sign. It's the same. It's vaporizing going this way. It's condensing going the opposite way. Do you guys agree? So, I will choose the same number as vaporization. What will I choose? 2259. But what will be the sign before 2259? Negative 2259. Does everybody see that? It's the opposite direction, so it is negative. Therefore, my answer is 10 times negative 2259, and I get my answer as negative 22590 joules. Everybody good? Did I finish the problem? I have to do my step 3. It's a slope. It's a slope. What is my equation, Gabby? It's a slope. It still hasn't clicked? What is it? It's a slope. Q equals What is the equation? M Cp of what? Cp of solid, liquid or gas? Liquid times change in temperature. Very good. So now the mass of my substance is 10.0 grams. I will go up to my table. Gabby, which number will I choose? Enthalpy of solid, liquid or gas? Liquid, which is 4.184 times 4.184. Now do I have to pay attention? Now I have to pay attention. What is my initial temperature? What was it? 100 degrees Celsius. That is my Ti. What is my final temperature? 50. My Tf equals 50. How do I solve for delta T? It is what minus what? 50 minus 100, which is negative 50. Miss McGrain, Keith is on the roll. He deserves way more candy than others. All right? So that is a negative 50. And now, if I multiply.
Good morning. Teachers, please pardon the interruption as we begin our morning announcement. Please make sure that channel 6 is on in your classroom at this time. Students, please stand for the pledge of allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. You may be seated. Please pause for 1 minute of silence.
Okay, guys, did you write the problem down? The last step is addition. Is that right? So go home, do your study guide, do your practice test, and study for the test.